In this video, we will learn how to write HSPICE netlist from scratch, understand every line, and successfully run simulations. The syntax and rules follow Synopsys HSPICE documentation, mainly the simulation and analysis user guide and reference manual. So these ones you will see here, and I have already downloaded some of those, and actually recommend using this one if you want to dive deep into learning HSPICE. So let's begin with the basics. HSPICE is not a schematic editor. It is a text-based circuit simulator, and everything is described using Netlist. And as you can see here, they say that Synopsys HSPICE is an optimizing analog circuit simulator, and you can use it to simulate electrical circuits in steady-state, transient, and frequency domains. So here you will not be building circuits and doing the simulation, running the circuit simulation, following schematics or something like that, but you will be using Netlist. Therefore, it's very important to understand how they are built and what rules you have to follow in order to have your circuit working according to what you want. Now, let's begin with the very basic stuff. How do we write comments in HSPICE? So, in order to write comments, we use asterisk, and then we write what we want to write. I'm gonna write here this simple RC circuit example. Whenever you want to write a comment, you're gonna have to use asterisk, be it at the beginning of the line or in the middle. Usually, you'll be following this structure: comments or title, and then you're gonna have elements, and then we're gonna have element, the element definition. After that, the analysis, commands, and output, commands. There we're gonna talk about it later, and you're gonna finish your netlist with .end. So you'll be following this structure most of the time. Let's now talk about nodes and ground. Let's talk about node naming, and I'm gonna give you some examples. It's very important to keep in mind that node 0 is always ground. It is always ground, and nodes are connection between points. And node names, they can be numbers or labels, but there are also rules that you have to follow in order to stick to the convention. And just like I said, you're gonna find everything in this manual. The one I'm using now is called HSPICE User Guide Simulation and Analysis. And if you go to page number 44, you will see here some of the conventions they use and what is legal or illegal to use. For instance, the period is illegal to use as a node name, but it is used for netlisting keywords such as tran or DC and etc. And it is used as a hierarchy delimiter when used in a node name. We have as well asterisk, just like I mentioned before, which is used for comments, as you can see here. And it is very important for you to become familiar with this. So it will be used for comments. In this manual, you're gonna find everything, much more details about what you can use and what you cannot, and when to use what you want to use. Here we have all this. Let's also check, just like I said before, whenever you want to write your simulation, you're gonna end, or whenever you want to write your netlist, you're gonna end with .end at the bottom of your netlist, because it is required. It is a required statement at the end of the netlist. So if you forget ground, your simulation will fail. Therefore, it's very important to keep in mind to always write it. Let's now talk about passive elements. Let's begin by talking about the resistor. Whenever you want to write a resistor or include in your circuit, you're gonna follow this structure. The resistor's name, its input, its output, and its value. We're gonna have this. R1 is the element name, and it must start with R. Then we have in and out, and these are nodes. After that we have 1 kilo ohm, which is the value. And capacitor. So to define a capacitor, we write it in this form, which is very similar to the definition of a resistor. Out 0, 1 micro, and for an inductor, I'm gonna do this. 10 millihenry. Whenever you want to use a particular unit, you can just write it in this way. You don't have to necessarily have the H here or F here. You can just use the unit name, and that's it. And it's very important to understand that these are case insensitive, so it really doesn't matter if you write like this or if you write like this. But most of the time you will see people write it like this just for the sake of convention. Let's now talk about independent sources. Whenever you want to define an independent source, it's very important to understand that the positive node should come first, and then you should have a DC or AC keyword. Let me show you. Let's say that we want to define an AC source. When I have this, and then V1 in 0, which represents ground, AC, and 1, the value. This means that we are defining an independent voltage source, an AC independent voltage source of 1 volt that is connected to ground and has its other terminal in. Know that AC magnitude is only used in AC analysis. Let's now define a transient source. Here we will have V1 in 0, and in this part we can also define something like a pulse. For that we're gonna write pulse. Know that the pulse has the following structure. This is the fall time. It's gonna be the pulse width. And lastly, I'm gonna have this one, which represents the period. So in this part, when setting the pulse, you're gonna have to follow this structure. Let me now type the full netlist. At the end of the netlist, you're gonna notice that I wrote as well .op, and this is basically a DC operating point, and then we finish with .end, which is the mandatory line that we have to have at the end of the netlist, which represents its end, of course. So I'm just gonna have this in a different file just to keep everything organized, and we're gonna run this simulation. So let's call this RC. And if we come here, it won't show up yet, but we have to upload the file. Alright, let's just clean this up. Then let's firstly run the netlist to make sure that there are no errors and everything is working fine. So -I RC SP, and you should make sure to write as well the extension file, otherwise it will not give you the proper result. And everything seems to be working fine. Let's also generate the output files. And for that, we're gonna use -O. After that, we can see that some of the files were added. These ones, the one that end with lease extension and IC0 extension. Let's now open this file. So this is the file you're gonna use whenever you want to see your text results. And here you will find basically all the information related to your simulation. Everything you should be able to find here. This is what we got. And these are also the elements that are in our circuit. And if we needed to check waveforms, your netlist would be a little bit different, and you would have to include as well something like dot trends, so that you have some other files printed out, and then you can plot your data using those files that will be generated. Also, make sure that you always check these manuals because they have a long series of manuals, and it will be very helpful for you to always check and always learn more. For instance, the one I'm using right now, it is part of this long series, and they have it here. So the one I'm using right now is this one, HSPICE User Guide for Simulation Analysis. You have also all these other ones that are very important. Let's say that you want to work with MOSFETs models. You would need these ones to understand clearly what is going on. Whenever you want to check anything, you can always come back and make sure that you are doing everything according to the rules and you are following everything that is supposed to be followed. And that's it. Now that you understand how netlists are structured, in the next video we will focus on DC analysis and DC sweep in much more detail. Thank you for watching.